Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagmani from Department of Computer Science, Arabhat College, University of Delhi. So in our series of database management systems, presently we are going through the topic of normalization. And if you can recall, in the previous lectures we have seen what actually the normalization is, and we have also covered the first normal form and second normal form of normalization. So today's agenda is third normal form, and we will also be looking into BCNF, which is Boycott's normal form. So let us begin at third normal form. If you can, the definition, if we go by the definition says a table is in third normal form if and only if it is in the second normal form and all its attributes, that means all its fields, are determined only by its candidate keys and not by any non-prime attributes. Now what does it mean? Let us try to see that. So when we say that we want any table to be in the third normal form, the first condition is that the table should be in the second normal form, and this goes with the other normal forms, this restriction. So for example, if we are talking about the second normal form, the table must be in the first normal form, and then we will apply some extra restriction onto that, and then we will say it is in the second normal form. Similarly, if we talk about a table to be in the third normal form, the first condition which it says is that it should be in the second normal form. Now, the other condition which it imposes is all the attributes should be, determined, should be, we can say, not accessed but retrieved only by the candidate keys and not by the non-prime attributes. Non-prime attributes are the, attributes which are actually, not able to identify any records uniquely. So all those attributes which cannot identify records uniquely are non-prime attributes. So what the condition says here, all the attributes should be determined only by the candidate keys. Candidate keys are the attributes which are the candidate for being the primary key. So if there is any non-prime attribute, any candidate key can determine that, but non-prime attributes should not be allowed to determine any other attribute. So for example, let us see a table which is named as borrowed books, and it is having only 2 records. So just for the sake of simplicity, we have taken only 2 records. The attribute which it contains are book number, the patron, who has kind of issued that particular, who has borrowed that book, the address of the patron, and what is the due date of it. Now here, if you can see what is the candidate key, that means which is the key through which you can uniquely identify the whole record. So obviously that is the book number, a unique key. So candidate key here is the book number. This may be a primary key, this may not be a primary key, because candidate key is satisfying all the conditions of being the primary key, but it, unfortunately we can say it is not the choice of the database administrator. So here the book number is the candidate key, and if we talk about a functional dependency, here we can see the address is dependent on the patron, while now if we can see there are 2 things. One, candidate key is the book number, we are sorted here. If we talk about the dependency between patron and address, we can see patron is on the left side of the arrow and address is on the right side of the arrow. This essentially means that address is dependent on patron. So address can be determined by patron. Now patron is not the candidate key, the candidate key is the book number. That means this particular table is actually not there in the third normal form. It is violating the second condition of the third normal form, that a any attribute, let's say address, is determined with the help of the patron, and patron is not the candidate key. So the idea here is all the attributes should be determined by the candidate key, not by the non-prime attributes. Now how are we going to rectify this, or how are we going to make this particular table into the third normal form? For that we need to decompose the table. So let us try to decompose the table. For its 3NF solution, what we have done is we have put in the address in a separate patron table. So book number, then patron and the due date in one particular table, and in another table we have patron and address. Now here if you can see both the tables, the patron and the due date are non-prime attributes and they are dependent on book number. Similarly, for the second table which we have just created after decomposition, the address we can say is now dependent on patron, or address can be determined by patron. But for the next table which we have just created, the patron is actually a candidate key here. So address can be dependent on the patron here in the decomposed table, but not in the previous one, because the candidate key of the previous table was not the patron. The candidate key of the previous was the book number. So what we can conclude from here is a relation can be called in the third normal form if it holds at least one of the following conditions for every non-trivial functional dependency between x and y, where y is dependent on x. Y should be a super key. That means if the attribute is dependent on x, then the attribute on which it is being dependent should be a super key. So x should be a super key, or it could be y should itself be a prime attribute, that is each element of y is a part of some candidate key. So either y itself is a prime attribute or x is a super key in case y is not the prime attribute. So at least one of these conditions, one of the following conditions should hold if we want a relation, if we want our table to be in the third normal form. Now let us take one more example for the sake of we can say clarity. Here we have a table which is named as employee detail, and what are the fields here are employee ID, employee name, employee zip, then we have state and employee city. So we can say 5 attributes here. Now from this you can easily make out which one is the candidate key, and then we will be keep on adding other keys onto it to make it the super key. So here in the above table we have candidate key as employee ID, and any superset of this employee ID will be the super key. So for example, employee ID along with the employee name, employee ID along with the employee name and employee zip, then employee ID along with the employee name, employee zip and employee state. All these are super key. Actual candidate key for which you cannot have more subsets is the employee ID. And all the non-prime attributes, what are the non-prime attributes? All the attributes except this employee ID are non-prime attributes. So for example, here if you can see, my employee ID is the candidate key. Any combination of employee ID along with other attributes will serve as the super key, because super key is actually any superset of the candidate key. But if we take candidate key alone, which is employee ID, now we have employee name, employee zip, employee state and employee city. So all these are non-prime attributes. Now what do we need here? So employee state and employee city are dependent on employee zip, and employee zip is dependent on employee ID. So this is what the situation in our table. I am just repeating it here again. State and city are determined on zip, and zip is actually dependent on employee ID, and this we can we can see here from this particular table. Now we have attributes being dependent on the non-prime attributes. So what do we need to do for that? To make or to convert this particular table into the third normal form, we need to break this table, or we need to decompose this table, because presently it is violating the rule of third normal form. The non-prime attributes employee state and employee city are transitively dependent on the super key employee ID. They are not directly dependent, but they are, we can say, are transitively and I'm sure I hope you understand what is the transitive transitive relation between three attributes. So for example, A is dependent on B, B is dependent on C. So we can say A is dependent on C. So that transitive relation holds here also in case of a dependency between attributes. So the non-prime attributes, so we have two non-prime attributes, employee state and employee city, which are transitively dependent on the employee ID or any super key of the employee ID. So that means it is violating the rule of third normal form. What do we need to do then? So in order to ensure the presence of this particular table in the third normal form, we need to move the employee city and employee state to the one new table, whatever name of that particular table we can have. So the name of the table we are going to have employee zip, and for that particular table employee zip is the primary key. So now the decomposed table is going to have three fields. One is employee zip, which is the primary key, then I am having employee city, and then I am having employee state. Now here what is happening, if you can see in this employee table, we have three attributes, ID, name and employee zip. So you can notice the dependencies here. Here in this case your employee zip is the primary key. Now in employee zip table, if we have this employee zip as the primary key, we have employee state and employee city as the two attributes which are dependent on zip, and this is we can say is serving the second constraints of the third normal form, in which we call the non-prime attributes, which are city and state here, are actually dependent on the candidate key, which is the employee zip here, or here we can say, for the sake of simplicity, we are saying it as primary key. So employee city and employee state are actually dependent on your employee zip. So now after this decomposition, my two tables are actually in the third normal form. So after this, till this point in this lecture, we have gone through the concept of third normal form, and we have seen what is transitive dependency, and do we really need to have a transitive dependency, or we need to have a direct dependency between all the non-prime attributes and the candidate key, and so on and so forth. So after this third normal form, we'll be moving to the so the natural instinct comes up that after third normal form we'll be moving to the fourth normal form, but here it is not like that. After third normal form, we are going to move to the Boycott's normal form. Boycott normal form, we can say it is actually a tweaked version of third normal form, because fourth normal form is we can say yet to come, that is something separate from this. So why we have inserted, or why the designers have inserted one particular extra normal form in between third normal form and fourth normal form, which is BCNF, Boycott's normal form. As I have told you that it is a tweaked version of the third normal form, or we can say simply it is the stricter form of third normal form. Now when we call that this a table is in BCNF, is in the Boycott's normal form, for that the condition is a table T is in Boycott's normal form if and only if for every one of its non-trivial dependencies y dependent on x, x is the super key for T. So here what are we trying to say, that in case of Boycott's normal form, all the dependencies or all the non-prime attributes should be dependent on the super key of the table. Here if we say y is dependent on x and we are going to write it as x arrow y, then x is the super key of t and y is an attribute which is dependent on x. Also we must notice that most of the tables that are in third normal form are also there in Boycott's normal form, because the difference or the layman difference, if you can try to figure out between the two, which is the third normal form and Boycott normal form, is about the dependencies on various keys. So there in third normal form we were talking about the candidate keys, and here we are talking about the super key. So basically Boycott's normal form, an advanced version of third normal form, which is, we can say, yes, more is stricter than the third normal form, and it is going to hold if every functional dependency in which a non-prime attribute y, which is dependent on x, so x should be super key of the table, and previously we were talking about the candidate key of the table. So for BCNF, the table should be in third normal form, where for every functional dependency where x arrow y, which is y is dependent on x, in all these such kind of functional dependencies, left hand side is the super key. So here, as I have already told you, that x is the super key of the table when we are writing x arrow y, that means y is dependent on x. So left hand side is the super key. Now let us take an example with an assumption that there is a company where employee works in more than one department. So we have an employee table in which we have 5 attributes. One is employee ID, another one is employee country, employee dependent, and then dependent type, and employee dependent number. So we have some employee IDs, then we have the employee countries, then employee dependents, employee department we have, then we have the type of the department, and then we have the number of the department, that is not dependent but the department. So employee ID, country, department type, and employee department number. So here you can kind of see the employee ID, which is 264, with country in India, is working on 2 departments, and that's what the assumption was, as I have just told you, that we are assuming for this particular example, we are assuming that there is a company in which the employees works in more than one department. So employee ID 264 is working in the designing department as well as in the testing department also, and then they have the different department numbers. So for designing it is 283, and for testing it is 300, and so on and so forth. Similarly, for the employee ID 364, the employee country is UK, which is referring to the last 2 records of the table. The different departments are stores and the development department or the developing department, with employee department number is 232 and 549. So here it is, this is what the structure on which. So if we can see the functional dependencies in this particular table, what are the functional dependencies? So first functional dependency is between employee country and employee ID. Employee country is dependent on employee ID. Similarly, the department name and the department type and the department number are dependent on employee department, which is the key, candidate key I am talking about. The candidate key is employee ID and employee department. So here from closely observing this structure, you will come to know that the candidate keys are actually employee ID and employee department. That means the combination of both, not the individual ones. While if we try to observe the functional dependencies, we have employee country dependent on employee ID, then department type and employee department number dependent on employee department. Now the table is not actually in the boycott's normal form, because if we talk about the candidate key, the employee ID and employee department are is the candidate key in combination, but employee ID and employee department are, if taken alone, they are not the keys. While my functional dependency says employee country is dependent on employee ID and department type and employee department number are dependent on employee department. Neither employee ID nor employee department are the keys alone. So that means this is not in boycott's normal form. Now in order to convert this given table into boycott's normal form, now listen very carefully here, we need to decompose this into 3 tables, because decomposition by 2 or decomposition into 2 tables will not work. Let's see how. So to convert the given table into boycott normal form, we decompose it into the 3 tables. One is the employee country table, so in which employee ID and employee country are there. Employee ID obviously is the we can say key, and employee country is dependent on the employee ID. Then we have employee department table, which is the second table, in which we have employee department, then department type and employee department number. This is the second table of the decomposition, which is going to reassure the existence of boycott's normal form. Another table is the employee department mapping table, which is taking the employee department and employee ID both, and it is giving us a mapping of employee ID and employee department. So bifurcation or decomposition of this particular situation into the 2 tables is not going to help, because let us try to recall the functional dependencies. The first functional dependency was between employee country and employee ID. The second was between employee department number and department type and employee department. So for the first table, which we after decomposition I am talking about, so for the first table the candidate key is employee ID. For the second table the candidate key is employee department, and for the third table a combination of employee ID and employee department is the candidate key. Now here if you can see the functional dependencies which are existing, this table can be called in boycott's normal form, because the left side part of both the functional dependencies are now the keys. Employee ID is the key for the first table and employee department is the key for the second table. So for the sake of clarity, let us take one more quick example. We have one example in which there is a manager who is working on a project, and that project is we can say hosted in a particular branch. So here we are assuming that branch is dependent on functionally dependent, the attribute of the branch is functionally dependent on the attribute of the manager, and manager is dependent on the project and branch, we can say. So here this particular table is in boycott's normal form because of the dependency of branch being dependent on manager, and manager is not the super key. So now the point is, how are we going to decompose it? So this decomposition I can say is going to if we go for the most trivial decomposition, in which we are giving a 2 table solution. One is manager and project and another one is the manager and branch. This solution is not going to preserve the dependency, which is manager being dependent on the project and branch. So here we can say, or we can have, with this, what is the problem? With this decomposition into two tables, the problem is one project cannot have two or more managers working on the same project at the same branch. So, the same branch, same project, and two or more managers are working on the project. So, this decomposition is going to give me this particular trouble, that we cannot have more than two or more managers managing the same project at the same branch. So, as we did in the previous example, this decomposition of decomposition of this table into two of the tables is actually not going to work. Instead, we need to decompose this particular table into three tables in order to have, in order to restore this for Boycott's normal form. So, in this lecture, we have covered the third normal form as well as the Boycott's normal form. After this, we have fourth normal form, fifth normal form, and domain key normal form also. But we will not be going into those details, because for undergraduate levels, most of the universities take Boycott's normal form as the kind of topic within the syllabus of normalization. So, we will be stopping our normalization here after this Boycott's normal form. And here is the list of references which is being used for the preparation of the lecture, and I will be beginning with a new topic in the upcoming lectures. Till then, please take care. Goodbye.